What is Hidden Inside Planets? It's a new book. Welcome back to Techstination. I'm Fred Fishkin, and joining us from Johns Hopkins University is author Sabine Stanley. Hi, Sabine.
Hello, so happy to be here.
Great to see you. And for those of us who are curious about space exploration and planets, this is a wonderful book. You're a Bloomberg Distinguished Professor of Planetary Physics at Johns Hopkins. Tell us a bit about what led you into this field.
Yeah, great question. So I kind of have an origin story. I actually grew up in a giant crater. So a meteor impacted the surface of the Earth 1.8 billion years ago in a town that's now called Sudbury, Ontario, Canada, and created this giant hole, which allowed a lot of natural metal resources to come up from the deep interior of the Earth and be used for mining and other purposes. So I was sort of in this environment that just screamed planetary science from a very young age. I wasn't really aware of it at the time, but I think it was subconsciously in me that I had to study the interiors of planets because I grew up in this impact crater.
That's a pretty interesting story. So you saw all this going on around you and you wondered, hey, how did that happen? Or where did that come from?
Yeah, exactly. And it was really interesting when I would later on in life go on to graduate school and stuff in the US. I would tell people where I'm from and they would all know it, right? And I thought I was just from this small town in Northern Ontario. And they're like, oh yeah, have you seen the shatter cones on the rocks in this area and so forth? So it was really great to hear about this very interesting place I grew up.
So in the book, What's Hidden Inside Planets, you talk about some strange sounding things, goings on, like diamond rain, frozen seas, iron snow. Tell us a bit more.
Yeah, absolutely. It's amazing to think we're so used to how materials behave on the surface of the Earth, right? Take water, for example. We're used to water being in its liquid form in, say, lakes or in its solid form when it's icy, things like that. But if you take a material like water and you suddenly put it deep inside the Earth or another planet, and the pressures are so high, millions of atmospheric pressures here on Earth, the temperatures are extremely hot, thousands of degrees. Materials just behave completely differently. So you can get all sorts of really cool things. So for example, in Jupiter, we have hydrogen that we're used to being a gas in the atmosphere. On Jupiter, if you go deep enough, it becomes a metal. And so it actually conducts electricity and creates magnetic fields. Helium rains out of that metallic hydrogen. So you get a helium rain. I don't know what kind of umbrella you would need for that. And then you can get iron snow in Mercury and even Ganymede, which is a moon of Jupiter. And of course, my favorite are the diamond seas and possible diamond icebergs that might exist deep inside Neptune and Uranus.
So if you catch the helium rain on your tongue, do you talk funny?
Good question. We'll have to test that out.
How mysterious is the interior of the Earth still? What don't we know?
Yeah, so the interiors of planets is very frustrating. We can actually see farther into the sun than we can into the Earth. So we have to use really sneaky methods to study the deep interior of Earth. So just like your doctor might use all sorts of scans to figure out what's going on in the human body, we have to use all sorts of scans to study what goes on inside planets. So we use, for example, fields like gravity, electromagnetism, and waves like seismic waves that travel through the Earth when there's an earthquake to kind of diagnose what is going on deep inside the planets. But it requires a lot of creative thinking in how you can actually create a process to learn about what's going on so deep beneath our feet.
I mean, is there the prospect of learning much more about the interior of the Earth, and why do we need to know it?
Absolutely. So first of all, there's so much we still have to learn. We don't fully understand, for example, the composition that is happening deep below us. So is there, in the iron core, is there some nickel mixed in there? What other elements are down there? It's all dependent and kind of would help us explain how Earth formed and how long it's going to provide us with things like our lovely magnetic field, which protects us from the solar wind, right? All of those questions really depend on what the composition is down there. The reason we really care, just like I mentioned, our magnetic field is generated down there. Our magnetic field protects life on the surface of the Earth. Oceans on the surface of the Earth are actually outgassed from volcanoes from the interior. So the reason we have kind of a nice habitable place to live here on the surface is because of the processes going on deep inside. There's also a dark side. A lot of the dangerous natural hazard processes on the surface of the Earth, things like volcanoes, earthquakes, are all also related to processes going on deep inside. So we want to understand them fully so that we can protect ourselves from them.
You know, I guess you opened up the can of worms. We see I don't, I always thought maybe this is clickbait. I don't know, but the stories about the magnetic poles shifting and things like that. What's the stuff, weird stuff going on? Should we be worried?
I don't think we should be too worried. So the good news is that if the Earth's magnetic field is starting to reverse, we think the process takes about 100 to 1,000 years. So we have time to adapt. So that's the good news. But we do have to think carefully about things like the satellites we have in orbit around the Earth. They are all protected by our magnetic field. And if the magnetic field gets weak and starts essentially going away, our satellites that do everything from give us GPS, your map apps and being able to plant seeds and land planes, to our communication satellite, all of those things are based on satellites in space. So we kind of want to protect them. There's also our power grid. Our power grid does not like large fluctuations in electromagnetic fields. And if we don't have the magnetic field protecting us, they're going to be susceptible to high energy particles coming from the sun in the solar wind, interacting with them and causing all sorts of disruptions that could blow power lines, for example. But we will have time to kind of adjust to that. So I would say it's not like an imminent threat, but it's something we should prepare for.
And it's gradual, doesn't like happen overnight. I hope.
As far as we can tell, it doesn't happen overnight.
Very interesting. Are planets very different on the inside from each other?
They can be. So we have different kinds of planets, right? The rocky planets, Earth, Mercury, Venus, and Mars, they're somewhat similar in composition, but they behave very differently. So for example, on Earth, we have plate tectonics, where the surface actually descends back into the Earth at subduction zones, and new crust and outer planet surface is created at mid-ocean ridges. Plate tectonics, we're the only planet that has them as far as we can tell, and we don't know why. We don't know why Venus doesn't have plate tectonics, or Mars or Mercury. So there can be differences in the interiors, and plate tectonics on Earth is responsible for all those things I told you makes the surface so nice and habitable. So it would be really nice to understand that process more.
What are your thoughts about planetary exploration and why it might be important?
I think it's really important that we send out spacecraft to explore the planets so that we can learn. You're essentially learning about family members when you explore a planet, right? Mars is a family member of Earth. We share genetics in some ways. We share the same building blocks, and we share nurture in some way. We share the same environment that we formed in. So we can really learn a lot about our planet by looking at other planets and asking, why isn't plate tectonics happening on Venus? Why doesn't Mars have a nitrogen and oxygen-based atmosphere, right? So I think it's really important to always look at the Earth in context with other planets.
When it comes to getting samples and learning about the interiors, the asteroid sample, Bennu sample comes to mind.
Mm-hmm.
You expect to learn much that's going to be valuable?
Absolutely. It's so exciting to have samples from Bennu. So the asteroids are basically the leftovers of the building blocks that built planets. So imagine that, you baked a cake and you wanted to know what the cake was made of. It would be really helpful if you had some like leftover crumbs of the ingredients you had, right? Like some of the flour on your counter, or maybe some of the eggs and stuff. That's basically what asteroids are. They're these leftover building blocks. And if we can go and study what they're made of, which we can from these samples that have been brought back to Earth, we can learn about the building blocks, the ingredients for the planet Earth.
What are some of the more exciting things that we've learned in recent years or months?
Oh my gosh, we've learned so much. I would go to Mars and talk about the Mars InSight mission, which essentially landed its first seismometer on the surface of another planet, and we discovered Mars quakes on Mars. And those Mars quakes told us about the interior structure of Mars. So we now know, for example, that Mars's iron core is actually a little bit bigger than we thought it was. And that has all sorts of implications for how planets form, and what processes governed how they evolved in time. So we now can ask the question, why doesn't Mars have an active magnetic field today, for example?
Interesting. When you think about threats to our planet, given how much time you spend thinking about the planet, what's top of mind?
Honestly, top of mind is ironically humans, right? We need to think about how to better, how to make sure that we are not damaging our climate so much that we can't live here anymore. And there are lots of threats related to increasing temperatures, increasing sea levels, and so forth that will make Earth much harder to live on if we don't work towards making our place friendlier and less, having the CO2 not rise as much, essentially.
That's a bigger threat than the worries about the magnetic shifting, I guess.
I think so, yeah.
The book again is What's Hidden Inside Planets. Sabine Stanley, thank you so much for spending time with us.
Thanks so much.